Hi, everyone. I've received a few questions about solving question 8 from the limiting and excess reagent question sheet. So I thought I would go through this as a video tutorial. And if you're stuck on some other limiting reactant questions, hopefully this will be helpful for you as well in solving those. First step for solving this problem, which I've already done, is to balance the equation. Now, one thing that might jump out of you the way I balanced it was I left the coefficient in front of oxygen to be a fraction. If you don't like that, just multiply everything by 2. And if you wrote 4, 7, 2, 4 as the coefficients, that's totally correct. In fact, in one sense, it's more correct because it's the simplest whole number ratio. Remember that the coefficients at this point don't just mean atoms and molecules, but also represent the mole ratio. So it's actually perfectly okay to leave it as a fraction as well. And we'll see it turns out it works out just fine when we're doing stoichiometry problems. So I'm going to leave it like that. If you doubled everything, some of your numbers will be slightly different, but we'll get the same answer. After balancing, our first step here is to determine the limiting reactant. A few different ways we can do that, but what I'm going to do is I'm going to take the masses of each reactant, convert those into moles, and divide them by the coefficients in the equation to help me to figure out which one's the limiting reactant. So let me do that now. So using the mass over molar mass equation, I've calculated the moles of each of my reactants. And now I'm going to determine the limiting reactant. And remember, our method for doing that is to divide these molar amounts by the coefficients of each of those substances in the chemical equation, and the lesser value will be our limiting reactant. Okay, so we see that FES is our limiting reactant. So recall that the limiting reactant is the one that runs out first, so it will determine the amount of product produced. And specifically, we're looking at the amount of sulfur dioxide produced. So for every 2 moles of FES which reacts, we produce 2 moles of sulfur dioxide, a 2-to-2 ratio or a 1-to-1 ratio. I've already calculated the moles of FES reacted. We have it right there in green. So therefore, the moles of SO2 is also going to be 8.65 times 10 to the negative 2 moles. The mass produced is 5.54 grams. Now that we have determined the limiting reactant and solved part B, where we solved for the amount of product produced, the last part of the question wants to know the percent excess left over. So a percentage is always the part divided by the whole. So the whole in this case, which will be the denominator of our percentage equation, will be this amount here of oxygen. This is the total amount of oxygen that we started with. What we need to do first is to determine how much oxygen was left over. So that's going to be the excess oxygen. So what we're going to do right now is use the ratio between iron 2 sulfide and oxygen to determine the amount of oxygen that actually reacted. So between oxygen and iron 2 sulfide, there's a 2 to 7/2 ratio. So the moles of oxygen reacted is equal to 7 over 2 divided by 2. So there's my ratio in the coefficients right there, multiplied by 8.65 times 10 to the negative 2, 0.0865 moles. The moles of oxygen reacted was 0.1514 moles. Once again, I found that by using the ratio in the balanced chemical equation, starting off with the limiting reactant and determining the amount of oxygen which reacted. Now I'm going to find the amount of oxygen left over. After the reaction stops, there are 0.5486 moles of oxygen gas left over. To calculate the percent excess of this reactant, I'm going to divide the amount excess divided by the total. Multiply by 100% to express it as a percentage. So we had this amount that was excess, and the total that we started with was 0.7 moles. So that means that 78.4% of the oxygen was in excess.